So we found these formulas for the slope and intercept of a line of best fit, and these formulas look really bad, but in practice they're not actually the worst to work with. So we're going to show how you can apply these to a fairly simple example. So we're going to have the points 1, 3, 2, 4, and 3, 6, and I've kind of sketched what the line of best fit might look like with, admittedly, a little bit of foreknowledge of what the answer actually is. So we want to kind of find what's the exact slope and intercept of the line that minimizes the squares of the distances between the line and the points. And we're going to use these formulas. And what we notice is even though there's a lot of sums going on, there's a lot of repeated things as well. So we don't need to actually find that many different things. We're going to need, what are we going to need? Well, we're going to need an n value. N is just the number of points we have, so that's 3. I'm going to need the sum of all the x coordinates, but that's just going to be 1 plus 2 plus 3, which is 6. I'm also going to need the sum of all the y coordinates. That's just going to be 3 plus 4 plus 6 equals 13. Then we need a couple extra things. I'm going to need the sum of all the x's squared. That's going to be 1 plus 4 plus 9 equals 14. And I'm going to need the sum of all the x's times all the y's. That's going to be 1 times 3 is 3, plus 2 times 4 is 8, plus 3 times 6 is 18. That's going to be 29. And now I'm just going to plug those into my formulas. My m0 value, the slope that I want, is going to be 3 times 29 minus 6 times 13 over 3 times 14 minus 36, 6 squared, I should say. And I put that in a calculator and I got 1.5. So that's going to be our slope. Now we want our intercept. So that's going to be sum of our x's squared, that's 14, times sum of our y's, that's 13, minus sum of our x's, that's 6, times sum of that product, that's 29, over, same thing we had earlier, 3 times 14 minus 6 squared. And that gave me something like 1.3 repeating, or 4/3, if I felt so inclined. Which means that the line of best fit will be y equals, we'll write 1.5 as 3 halves, why not? 3 halves x plus 4/3. Which I hope you sort of believe is kind of what I have drawn here. So does this have a slope of 3 halves? Sure. Does it have a y-intercept of 4/3? Why not? And as we see, it kind of snuggles itself in between these 3 points in a way that does minimize the distance quite well. So that's how you use that formula to actually find the line of best fit.